Today's lesson is going to focus on Newton's 3 laws of motion, identifying keywords to determine which law a particular question is asking. Okay, so here's Newton's first law of motion. It is the law of inertia. The second law is dealing with force equals mass times acceleration, and the third one is law of equal and opposite forces. So here we're going to highlight some keywords to keep in mind. The highlighter. Here we go. So the first law you need to focus on: an object at rest is going to stay at rest. So here it is, will stay at rest. Highlight this, excuse my highlighting. We need to focus on unbalanced forces. These are keywords. And an object in motion will stay there, will stay still until the unbalanced again force comes and acts on it. So what does that mean? Things keep moving or stay at rest unless a net force acts upon it. So Newton's second law, the keywords that we need to focus on is force. Here's a formula: equals mass times acceleration. The acceleration, here's another keyword, is proportional to the force acting on it, inversely proportional to its mass. Here's the word mass. So you can also think of Newton's second law as forces cause acceleration while mass resists the acceleration. Third law is law of equal and opposite forces. Here we need to focus on equal and opposite. Equal and opposite. Okay, most importantly for every action. So we need here action and reaction. Okay, so here's some examples of inertia. The more mass, more inertia. Here's some definitions about force. What is a force? It's a push or a pull. The unit for force would be newtons with a capital N. It's used to measure force. The net force, here you have arrows in opposite directions. You will subtract the amount of force being applied to an object. And there's an example at the bottom. So throughout this presentation, we're going to be practicing these 3 laws. Okay, so keywords in practice for the first law of motion. So if a person pulls on a cart to the right, here's a keyword, it's going to the right, with a force of 10 newtons, and a second person pulls to the left, so it's an opposite direction, with a force of 3 newtons, what is the net force? Okay, what's the net force? So how are we going to approach this? Okay, so since the forces are in opposite directions, you will subtract 10 minus 3, which equals 7, going to the right because the right has more force. So let's see here. Okay. So you have a 7. Oops. 7 minus, because they're going in opposite directions, 3 equals 4. And it's very important that you write your unit. Always, always, always for the net force. Okay, so next. Next is the second law of motion. Let me go ahead and change this to the highlighter. You want to focus on the formula. Force equals mass times acceleration. What does this mean? The more mass an object has, it's going to require more force. Okay? For the same mass, more acceleration requires more force. So what does the second law mean? You accelerate or decelerate quickly, use more force, and wear out engine parts and brake faster. So here is a way to use this second law formula. You have force equals mass times acceleration. The line right here at the top means whatever crosses that line, you're going to divide. Whatever crosses this middle line here, you're going to multiply. So depending on what the question asks you, you have to pay attention to the variable. If a question asks you what is the force, you will cover up the F and then multiply the mass times acceleration. If the question asks you what is the mass, you cover up the M and you divide force by acceleration. If the question asks you what is the acceleration, you cover up the A and force divided by mass. So here are some strategies to consider when you are trying to figure out what variable to solve for. So you would read the problem and figure out which variable is missing. Cover the missing variable, read the other variables. If they are next to each other, multiply. On top of the other, you divide. So let's practice. Okay, so here we're looking for key words. A 20 kilogram bike accelerates at 10 meters per second squared. With what force, here it is, what force was the person pedaling? So we come over to the triangle, cover up the F, mass times acceleration. Another thing to consider is the units right here. Mass for kilograms, force for newtons, and acceleration meters per second squared. So the next question. If a person is pushing a cart with a force of 40 newtons, here it is, your 40, here's the force, 40 newtons, that's the unit for force, and it accelerates, there you have acceleration, 0.5 meters per second squared. What is the mass? So what variable needs to be solved for? Mass. You go over to the triangle, cover up the M. The triangle says that you will divide force by acceleration. The next question, what is the acceleration? So you are looking for acceleration of a 3 kilogram rock that is thrown with a force, here's the force of 18 newtons. Okay, so what are you going to solve for? Acceleration. So you cover up the A in the triangle, force divided by mass. Okay, so let's go to Newton's third law of motion. For every action, there is an equal or opposite reaction. So here's an example. The air coming out of the bottom of the balloon pushes downward, and then the reaction is the balloon that's going to fly upward. It's going to go upward. Here's a tennis ball. What is the action? The ball hitting the ground. The reaction is that the tennis ball is going to bounce back up. An important concept to consider is forces come in pairs. So let's go ahead and tie all of this together. Over here you have a summary of the different laws, the 3 Newton's laws, and here you have some practice to try to figure out which law the statement is talking about. And we're going to look at key words. When you put a book on a table, that pushes on the book. So here's one force, putting the book on the table. And then here's another key word is that the table pushes on the book. So you have pairs of forces. You have a pair of forces there. Okay, so it's the first, second, or third law. A person pushes forward, keeps wanting to go in a straight line. A person is pushed forward and will continue to go in a straight line, right? And their seatbelt stops them. Okay, so here, this one would be the first law. Remains at rest, is wanting to go in a straight line unless an unbalanced force acts upon it. So the unbalanced force in this case would be the seatbelt. If the seatbelt wasn't there, the person would continue to go forward. A larger car takes more force to move. So you need to consider second law. Okay, second law, more force for acceleration. A person leans on the wall and the wall pushes back. So here's the first action. The person leans on the wall and the wall pushes back. So you have two forces. That would be third law. A brick sits on the table. So here it is, a brick that's just sitting there until you push it. So an unbalanced force has to go and move that brick. So that would be first law. Okay, so now after the lesson, you'll have opportunity to practice more.